how to obtain electrical analogous system. The first thing is we have to write the mechanical model for this. Now, no need to write free body diagram. The examination you have to draw, but by looking at the diagram, we can directly write. But in the examination, it's better to put free body diagram for the sake of mass. M1 d square x1 by dt square plus k1 x plus v1 dx1 by dt plus this k2 is connected with m1, therefore k2 x1 minus x2 equal to f of t, applied force. This is the first equation. The second equation is m2 d square x2 by dt square. This is for mass. Then for another element connected is this k2. Therefore, k2, here the reference is displacement is x2. Therefore, x2 minus x1 plus k3 x2 minus x3 plus b2 d by dt of x2 minus x3 equal to 0. No applied force. For third mass, m3 d square x3 by dt square plus k3 x3 minus x2 plus b2 d upon dt x3 minus x2 equal to 0. No applied force. These are the three mechanical equations. What is analogous electrical system? M should be replaced by L1. L1 d square q1 by dt square plus k equal to what? 1 by c1 q1 plus r1 dq1 by dt plus k2 again 1 by c2 q1 minus q2 plus equal to v of t, applied voltage. Now we know that dq by dt equal to I and q equal to integral of I dt. dq by dt equal to I and q equal to integral of I dt. So if you replace this in terms of I, what you will get? L1 d I1 by dt. Because one derivative reduced. Because dq by dt equal to I. Therefore, if you differentiate once again, you will get di by dt equal to d square q by dt square. Therefore, we can write di by dt, L1 di by dt plus 1 by c1, q equal to what? Integral of I dt. Therefore, integral of I1 dt plus dq by dt equal to I. Therefore, R1 I1 plus 1 by c2 q1 minus q2. q1 equal to what? Integral of I1 minus I2 dt equal to v of t. So we got in terms of current. What and all we got? Similarly, for second equation also we can write L2 d square q2 by dt square plus K2 is equal to what? 1 by C2 Q2 minus Q1 plus 1 by C3 Q2 minus Q3 plus V2 equal to what? R2 d by dt of Q2 minus Q3 equal to 0. So if you write this in terms of current, what you will get? L2 d I1 by dt plus 1 by C2 integral of I2 minus I1 dt plus 1 by C3 integral of y q equal to what? Integral of I dt. Therefore, integral of I2 minus I3 dt plus R2 multiplied by I2 minus I3 equal to 0. This is second equation in terms of current. Third equation in terms of charge equal to L3 t square Q3 by dt square plus 1 by C3 Q3 minus Q2 plus 1 by C2 Q3 minus Q2 equal to 0. That's all, no applied force. So if you take this equation, this is the second Kirchhoff's voltage law equation. This, if you write this in current L3 di3 by dt plus 1 by C3 integral of I3 minus I2 dt plus 1 by C2 integral of something wrong here. I2 minus I3. Third equation, how many you will get? K3 B2. 1 by C3 B2 equal to B2 equal to what? R2 d by dt of Q3 minus Q equal to 0. That is equal to R2 multiplied by I3 minus I equal to 0. If you consider these three equations, we can draw the electrical analogous of mechanical system. What is the first element? L1. There are three loops are there. Three loops are there. Three loops are there. Three loops are there. The current through the first loop is I1. Current through the first loop is I1. Current through the second loop is I2. Current through the third loop is I3. What is current through this path? In this direction, I1 minus, if you see in this direction, I2 minus I1. If you see in this direction, I1 minus I2. While considering first loop, I1 minus I2. While considering second loop, I2 minus I1. Because we are considering this direction as positive. Okay, three loops are there. If you consider the first equation, L1 di1 by dt, that is only I1 is flowing. Therefore, we can draw this in any one of these three sides. You can draw this in any one of three sides, A, B, C, D. Except BC, you can draw either at AB or AD or DC. So we will write at AB, inductor L1. Then 1 by C1 integral of I1, only current only. That also we can draw at across AB. This is C1. Then R1 I1, that is also I1 only. We can draw either here or here. Only I1 has to flow. We'll draw here R1. L1, C1, R1. Then C2. The current through C2 is I1 minus I2. Therefore, C2 must be here. Two currents are flowing through that. I1 and I2. Then V of T is the applied voltage that is in the first loop only. That is here. V of T. That's all. First equation is over. Consider the second equation. L2 I2. L2 I2. di2 by dt. L2 di2 by dt. Only I2 is flowing. Therefore, we have to draw here L2. Then 1 by C2, I2 minus I1. Already we have drawn that C2. Therefore, no need to draw now. 1 by C3, it is between second loop and third loop. Therefore, it should be here. This capacitor is here. C3. R2. R2 is between I2 and I3. That is also here. R2, C3. How many elements? Inductor 1. This capacitor already drawn. Second, C3 drawn. Third and R2. 4 elements. 1, 2, 3, 4 elements. That's all. So we can complete the second loop. Third loop, L3. Through L3, only I3. Therefore, we have to draw here L3. C3. C3 is between I2 and I3, already drawn. R2 is between I3 and I2, already drawn. That's all. So we can close this. That's all. This is electrical analogous system of mechanical system. This is called voltage analogy. Voltage analogy. Voltage analogy. Force voltage analogy. We can say that force voltage analogy because force is analogous to voltage. Therefore, force voltage analogy. In the same way, we can obtain force current analogy. That is also possible. Force current analogy. For here, what is the source used here? The source is voltage source. Voltage source. If you use a current source, then it is called force current analogy. Force current analogy. What is the difference between voltage source and current source? What is the difference between voltage source and current source? Ideal voltage source, ideal current source. What is the difference? When we can say voltage source is an ideal voltage source? Suppose I am having a 5 volt ideal voltage source means I can take any amount of current from that voltage source. Its voltage remains 5 volt. Voltage remains 5 volt. Then it is called ideal voltage source of 5 volt. Similarly, current source means the current remains constant. Any number of, suppose I am connecting one resistor, the same amount of current flow through that resistor. If I connect 2 resistors in series, then also the same amount of current will flow through this. Then it is called current source. It will give same amount of current irrespective of number of load. It's very difficult to imagine because we practiced to imagine only voltage source. Current source means even voltage will vary, current remains constant. The amount of current given by the source remains constant. A number of parallel paths, if you include, say, same amount of current will be divided into many branches. For that, we will use Kirchhoff's current law. That we will see. Force current analogy means the circuit will be with current source. So for this, this is the circuit in which current source is there. One resistor, one inductor, and a capacitor are in parallel. So what is the equation? I1, current through this is I1, current through this is I2, current through this is I3. What is applied? This current coming from this is I of t. Total current is I of t. I of t equal to I1 plus I2 plus I3. What is current through this path? All are in parallel. That's why voltage is same. Voltage across each element is same. Applied voltage is V. Therefore, I1 equal to V by R. I2 equal to what? L dV by dt plus what is 1 by L, 1 by L integral of V dt. Voltage across the inductor is 1 by L V dt plus C dV by dt. Voltage across the current through the capacitor is C dV by dt. The current through the inductor is 1 by L, 1 upon L integral of V dt. So the equation is 1 upon L integral of V dt, V by R, C dV by dt. This is one is I1, this is I1, I2, and I3. Total current is I. Always it remains same for a current source. But we know that V equal to rate of change of flux d phi by dt, or phi equal to integral of V dt. If we bring this dt this side and integrate on both sides, we will get phi equal to integral of V dt. This you should remember. Therefore, we can write V equal to d phi by dt. Therefore, dV by dt equal to d square phi by dt square. C d square phi by dt square. V equal to what? D phi by dt. So we can write like this. Integral of V dt equal to phi. Therefore, phi upon L. So we can write in terms of phi also. Rate of change of flux equal to voltage. This is the rate of change of flux equal to applied voltage across the element. So this is identical to mechanical equation. You go to that again. This sum, it's again. What is the first equation? M1 d square x1 by dt square plus K1 dx1 by dt plus B1, K1 x1 plus B1 dx1 by dt plus this K2. For this K2, we can write K2 multiplied by x1 minus x2 equal to applied force F of t. So now we can write in terms of force current analogy. Force current analogy. So force current analogy is M is identical to C. X is identical to flux. B is identical to 1 by R. Dx by dt equal to V. Already we have seen. K equal to 1 by L. K equal to 1 by L. B is 1 by R. Earlier B equal to R. Now B equal to 1 by R. Anyhow, there is no change in B. Earlier R, now 1 by R. But earlier in the force voltage analogy, M is identical to L. Similarly, K is identical to C, 1 by C. Here 1 by L. That is the only difference. Instead of R, earlier B is identical to R. Now 1 by R. That is the difference. So wherever you find M, replace by C. Replace by C. Wherever you find B, replace by 1 by R. Wherever you find K, replace by 1 by L. You will get electrical force current analogy. So what we have to do? Wherever you find M, replace by C1 d square phi 1 by dt square plus K1. What we have to do for K? For K, what we have to do? 1 by L. So we have to put 1 by L1. 1 by L1 phi 1 plus B equal to 1 by R1 d phi 1 by dt plus K2 should be replaced by 1 by L2 phi 1 minus phi 2 equal to I of t. Now we have to write in terms of voltage. D phi by dt equal to what? Voltage. Therefore, C1 d V1 by dt plus 1 by L1 phi equal to what? Integral of, we have already written this. Phi equal to integral of V dt. Therefore, integral of V1 dt plus d phi by dt equal to V. Therefore, V1 by R1 plus 1 by L2. 1 by L2. Therefore, 1 by L2 integral of V1 minus V2 equal to I of t. We got one equation. The same way we can write for mass 2. M2 d square x2 by dt square plus K2 x2 minus x1 plus K3 x2 minus x3 plus B2 dx2 upon dt x2 minus x3 equal to 0. If you replace this by current analogy, C2 t square phi 2 by dt square plus K2. K2 means 1 by L2 phi 2 minus phi 1 plus K3 1 by L3 phi 2 minus phi 3 plus B2 equal to 1 by R2 d by dt of phi 2 minus phi 3 equal to 0. So now we can write in terms of voltage C2 dV2 by dt plus 1 by L2 integral of V2 minus V1 dt plus 1 by L3 integral of V2 minus V3 dt plus d phi by dt is voltage V2 minus V3 divided by R2 equal to 0. This is second equation. We have to write the third equation. What is third equation? Third equation is M3 d square x2 x3 by dt square plus K3 x3 minus x2 plus B2 d by dt of x3 minus x2. No applied force, therefore equal to 0. This is third equation. If you write in terms of current, M3 is C3 d square phi 3 by dt square plus what is K3? K3 should be replaced by 1 by L3. 1 by L3 phi 3 minus phi 2 plus 1 by R2 d by dt of phi 3 minus phi 2 equal to 0. Now, if you write in terms of voltage, d phi by dt equal to V voltage. If you write to use that, you will get C3 d phi 3 by dt. Sorry, dV3 by dt plus 1 by L3. Phi equal to integral of V3 minus V2 dt plus 1 by R2 multiplied by V3 minus V2 equal to 0. This is third equation. Three equations are there. Three equations are there. This is one equation. This is second equation. This is third equation. Now we have to draw the circuit, that's all. KCL circuit. We are doing in the reverse direction. In circuit theory, electric circuit analysis, for given circuit you wrote KCL. Here, for the given equation, you have to draw the circuit, that's all. Reverse process. So first equation consists of how many elements? 1, 2, 3, 4, 5 elements, including I of t. How many voltages are there? V1, V2, V3. Therefore, 3 nodes are there. If you include one more reference node, 4 nodes are there. 3 equation means 4 nodes. One node will be taken as a reference node. So what we can do is, we have to take one reference node. We have to take one reference node. This is the reference node. Reference node. Another 3 nodes. One is V1 node. Another node is V2 node. Third node is V3 node. 3 nodes are taken. V1, V2, V3. One node taken as a reference. If 4 nodes are there, we will write 3 equations. One node will be taken as reference. Then we will go to the first equation. First equation says C1 dV1 by dt. It is the voltage across this capacitor is only V1 only. Therefore, what we have to do is across V1 and reference, we have to draw the capacitor C1. Then again go to that equation. Second, L1 by L1 integral of V1. Again, only V1. Therefore, we come here and draw an inductor and connect to the same reference L1. Again, go to that equation. V1 by R1. V1 upon R1. One resistor, only applied voltage is V1 only. V1 only. Therefore, again, take here one resistor R1. Then go to this circuit. 1 by L2, voltage across V1 and V2. This inductor is across V1 and V2. Therefore, what we have to do is, we have to draw this inductor between V1 and V2. This is V2. This is V2. L2 is between V1 and V2. Then again come here. The right hand side is the applied current source is I of t. That also in the first node. In the first node. Therefore, we can draw that also. Current source in the first node, I of t. That's all about first equation. Now go to the second equation. Second equation, C2 dV2 by dt. Only across C2, only V2 is applied. Therefore, the C2 will be like this. C2. Between V2 and reference. Come again. L2 is between V2 and V1, already drawn. L2 is between V2 and V1. See that? L2 is between V1 and V2. L2 is between V1 and V2, already drawn. L3 is between V2 and V3. L2 is between V2 and V3. L2 is between V2 and, L3 is between V2 and V3. And R2 is between V2 and V3. R2 is also between V2 and V3. That is also between V2 and V3. R2. Yes, R2. R2 is between V2 and V3. R2 is between V2 and V3. No sources in node 2 and node 3. That's all for about third node. C3 is between V3 and reference. Here, C3 is between V3 and reference. Therefore, we have to draw one more capacitor between V3 and reference. That is C3. Then come to that equation. L3 already drawn. L3 already drawn. R2 already drawn. That's all. This is a circuit, but it looks ugly. That's why we have to draw again. We'll draw here. We'll draw here. Current source I of t. R1. C1. L1. Then this is V1. This is also V1. This is also V1. No element is connected. That's why all are in V1. Between V1 and V2, this is V2. L2 is connected. L2 is connected. Between V2 and C2, between V2 and C2, between V2 and reference, C2 is connected. This is reference. Between V2 and V3, L3 is connected. This is V3. Between V3 and V2 and V3, R2 is connected. Between V3 and reference, C3 is connected. That's all. Now it looks good. Same circuit, but we redrawn like this. This is to understand. So everything is between reference and some node. That's why I drawn like this. But both are same. This is force current analogy of given mechanical system. Force current analogy of mechanical system. Current source is theoretical source. Current source is theoretical source. Nowadays, current sources are available. Current sources are available, but you cannot buy like battery like current source. A device will be available that will give constant current. That will give constant current. Such current sources are available. So you can do this experiment also. So if you want to simulate a mechanical system in the electrical way, you have to find this analogy.